Hey algebra friends, so we just finished learning about rational expressions, how we can simplify them, and how we can multiply and divide them. And it usually starts with factoring, and then finding domain, and then canceling. But the other thing that we can do is also subtract and add them. And this one's a little bit trickier. Even though we're pretty good with adding and subtracting basic fractions, like if you look at this simple example, we could do that pretty well. The more serious ones come about here, and you look how serious that one is. But first, can we go back? Let's do the simple example really quick, just to make sure we're okay with adding and subtracting fractions. Now, when you have to subtract and add fractions, of course you have to find what's called a least common denominator, right? So between 1 over 2 and 2 over 3, what's your lowest or least common denominator? And as you can see, between the 2 and the 3, they don't have anything in common. They don't have the same factors that we could maybe borrow. No, they don't. So a lot of times if they don't have it, what the shortcut was you basically just multiply the two numbers together and you get 6. Or you just thought about it and you think, okay, what's a good common denominator that is the lowest between 2 and 3? And here it would be 6. And so what we had to do is change each fraction so that they had the same LCD. So I'll take the 1 over 2, and in order to get 6 on the denominator, I'm going to multiply top and bottom by 3. And for the 2/3, to get the 6 in the denominator, I'm going to multiply top and bottom by 2. All right, so this becomes 3 over 6 plus 4 over 6. Do we have the same denominator? Yay, we do. So therefore, what we do is to add them, you keep the single denominator. We don't add denominators. Keep the single denominator, and we just basically add the tops. 3 plus 4 is 7. Okay? And that's basically what we're going to do over here when we talk about these examples. But finding this is the hard part. Finding the LCD between the fractions when they're rational expressions is a little bit trickier. Let's take a look. In the series example, here's what we have. We have these two factors here. And even though visually it looks like they have some things in common, do you notice they both have x's? But other than that, really look at the big picture. Between this factor and this factor, there really is nothing in common. And so what the lowest common denominator is going to have to be is both factors multiplied. Okay, so that's what we're going to have to choose for our LCD, which means, therefore, we're going to need to multiply each denominator by the other one, if that makes sense. So, for example, on this left fraction, I'm going to need to change this by multiplying it by 3x plus 4 in order to get that LCD that I chose here. Now, if I do it to the bottom, I got to do it to the top. Okay? That's going to give me a good common denominator. And on the right fraction, we're going to multiply this one by the other denominator. But again, we got to do it top and bottom. Okay, let's keep playing with this, but I'm going to need a little bit more room. So I'm going to come down here a little bit. This means, all right, the new left top fraction. If we do the 3x and we do the x and we multiply, well, basically for now I'm going to leave it undistributed just so we can visually see what it looks like. Here we go. Okay, the new left fraction looks like this. The new right fraction looks like this. Okay, that's pretty good. Notice that they have the same denominator, so we're pretty much good to go in terms of adding or subtracting. Now, it'd be really tempting to say, look at each fraction. Do you see how I can cancel top and bottom? Ooh, over here I cancel. No. If you do that, unfortunately, you're going to go all the way back to the beginning and start all over again. You don't want to cancel. You want to keep the same denominator. That's the point. Okay, now we're going to go ahead and subtract these, but in order to do that, it's probably easier if we go ahead and simplify this friend and simplify this friend. Okay, so the top left would be 3x to the 2 plus 4x. Great. And on the top right, if I distribute the 2, I'd be 2x minus 6. Okay. But the point is we have the same common denominator, so we're good to go. Notice I'm not going to FOIL out those denominators because maybe in the end, maybe more things are going to simplify, so it's probably easier if they stay factored. So don't distribute. Keep them factored. Don't FOIL. Stay factored, my friends. All right, here we go. If I subtract the tops, I should have 3x squared plus 4x minus. Now I'm going to subtract the entire right numerator. So parentheses, please. Okay. And that's divided by my single common denominator. Great. Okay, it's looking pretty good. We can probably simplify a little bit of the numerator now by distributing that negative and gathering sort of our like terms here. How about 3x squared plus 4x minus 2x plus 6 over our LCD. Great, we're almost done. Why don't we just simplify that top now? How about 3x squared? And we have minus 2x. Sorry, that's a plus 2x, Mr. Brown. Plus 6 all over our LCD. Okay, there's our final answer. Now, that looks really, really good. What's tempting to do now, it's not a bad idea to check. Can that numerator be factored? It's always a good idea to check because maybe there's a factor in there that's going to cancel with one of these guys on the bottom. And so I can make it even more simplified. So we should check. But looking at it, if I do the AC method, I notice that 3 times 6 is 18. If I need two numbers to multiply to give me 18 and add to give me the 2 in the middle, it's just not going to work. So this one doesn't factor. The other thing that we should add is talk about domain. Now notice on these kind of problems, we're doing domain all the way at the end. That's fine because the denominators are not going to change. So we're not going to be canceling any of the denominators, hopefully. So we can just look at the denominators now and say, well, from the left denominator piece, I can say that x cannot be equal to negative 4/3. You could do it like we did last time. And it cannot be equal to 3 from the right parentheses. All right. So we should always check our domain when we're done as well. All right. That's a good basic example of how to add or subtract rational expressions. Find a good LCD, adjust your fractions if you need to, and then add or subtract. But maybe, just maybe, you're going to have to do something first. And this is a good starting point just in case. Maybe the denominators need to be factored. So it's a really good idea to look through all your denominators and see, can I factor them first? Because that's going to help me find a really good LCD. So good step one, before you think about changing your fractions, when you find your LCD, see if you can factor all the denominators first. Let's try this example down here on the bottom, and you'll see how that works. Now I'm going to need a lot more room, so I'm going to give you a second if you want to go ahead and pause the video and copy down everything you have here, and then I'm going to erase it all. All right, bye-bye, friends. All right, can you take a look at that left, simpler example, and just think about how do we add and subtract when there's more than one? It's getting a little more complicated, too. I'm going to add 1/6 plus 3/4 and then subtract 2/3. Do we have a good LCD here? Let's see. I need a number that all three of these denominators can divide into evenly. And there's a very simple way of just literally multiplying every single denominator. 6 times 4 times 3. Obviously that's going to work because if they all multiply to make that number, of course they're all going to divide into that number. But you can see that number is going to be pretty huge. That's going to be 72. And that's a little bit big. Is there a lowest common denominator? Is there one that's even smaller than that? And it's actually going to be 12. But how'd you guess that without just sort of guessing and thinking about it? Well, here's another method. And this might be helpful for some of you. I've seen this before. I'm going to take every denominator. I'm going to factor the denominators. They're just numbers, but what I'm going to do is I'm going to write them into factors. For example, 6 is 2 times 3, right? 4 is 2 times 2. And 3 is just 3. 3 times 1 is just 3. Okay, the way to find a good LCD is to just start picking numbers that appear in more than one spot. Can you find numbers here that appear in more than one spot? For example, I see a 2. I can take a 2 from here and a 2 from here. Okay, so LCD would be 2. Notice I didn't take the second 2 yet. I'm only going to take 1 from each if I can. How about 3s? I see there's 3 in more than one spot, so I'll take a 3 out. Do we have any leftovers? Yeah, that leftover 2 here is a good part of our LCD. And what is 2 times 3 times 2? And that's 12. So that's one way of finding a good LCD is you factor the denominators, take common pieces, and then take the leftover pieces, and you've got to multiply together. So then if we do that, we're going to change every fraction here. The 6 on the bottom is going to be 12, so I'm going to multiply top and bottom by 2. The 4 needs to be multiplied top and bottom by 3. And the 3 is going to be multiplied top and bottom by 4. Okay, I'm not going to go through the rest of that problem. I just want to show you an interesting way to find an LCD when it's more complicated. And the reason is, let's go ahead and move our eyes over to this series example where there's not only more than one term, but it's just very complicated looking. Look at these denominators. Ugh. And again, a great common denominator would be, let's just multiply all 3 of these pieces together. But who wants to do that? This is going to be huge if you do that. Can we find the lowest common denominator? And so I go up to my little hint, the star that I have up here, that said, why don't we try to factor everything first? And I see on this bottom right one, I can actually factor this one, right? This is a difference of squares. Okay, so now the first, second, and third denominators are all factored. So what would be a good LCD? Do you see any factors that are common in more than one spot? I see the x minus 1 is common here and here. So I'll take an x minus 1. Now I don't see anything else, any other factors that are common in more than one spot. So what we have left are just the leftovers. So I have a leftover in x plus 1. And I have a leftover of just an x. That, my friends, that's going to be my lowest common denominator. Again, I factored all my denominators. I took factors that were common in more than one spot. And then I took any of the leftovers. Okay, now in order to do this, we're going to have to take a lot of room here because we're going to have to be multiplying these denominators by a lot more than just one factor. I might need more than one factor. So Mr. Brown needs more room. Let's get rid of all this space. Got enough space on your page too, friends? All right, here we go. Let me work over here on the left side. So I'm going to take 3 over x minus 1. That's going to be need to multiply by. Well, look over here at our LCD here, folks. I already have an x minus 1. So whatever I'm missing is what I'm going to have to multiply by in order to make that common denominator that they're all going to have. So that x minus 1 is going to need to be multiplied by x plus 1 and x. Where? Top and bottom. Okay, that's going to give me a good common denominator. I'm going to have to mess with the numerator a little bit too, right? Okay, minus 2 over x is the second fraction. Now let's see. Look over on the LCD. Do you see that we have the x, and what do we not have yet in our denominator? These two, friends, right? That would make the LCD. So top and bottom, change your fraction. It's very methodical, right? It's just a little bit more steps. And then our last fraction was x plus 3 over, notice I'm going to use the factored form here, because then I'm going to be able to see more of what I'm missing. This one has a lot of the LCD, right? The only thing I'm missing is just an x. So I just need to multiply the top and the bottom by an x. All right. So it looks like I'm going to eventually have all the same denominators. Again, I'm going to keep it factored. I'm not going to multiply out yet. But I think I will multiply out the numerators now so that I can combine everything pretty easily. Okay, so how about on the top left, let's see, that's basically 3 times x squared plus x. Okay, so really, that fraction becomes 3x squared plus 3x over our LCD. Great, that one's good to go. The second one, let's see, this is going to be 2 times, oh, that's just a difference of squares, which is just x squared minus 1. So that should be minus 2x squared minus 2 over, again, LCD. I'm just going to write all the LCDs the same anyway, so that they visually look the same. And then finally, the last piece is just going to be a quick distribution. How about x squared plus 3x over, again, LCD. Great. Okay, this is looking really good. I think everything's good to go. We have same common denominators, right? These look pretty good. I'm only going to keep one common denominator, right, when I'm done. And I'm just going to add and subtract the tops. But look at our tops. Okay, this one looks fine. Ooh, but look at that. That's going to be subtraction. So just be careful. That negative is going to have to multiply into each piece, right? I think I'm going to do that right away in the next step. and then this one's being added, so that one's okay. Ready? Let's put it as one huge fraction. Come on up here, buddy. Okay, denominator, ready? X minus 1, x plus 1, common denominator, yay. The tops, ready? We get from left to right, 3x squared plus 3x. Good. Watch this. Minus 2x squared plus 2, right? I distribute the negative right away. And then plus x squared plus 3x. All right. Can we simplify that, friend? Let's look at all of our common terms that we can add together. And I think I have a positive 2x squared. I think I have a positive 6x. And methinks I have just a positive 2 left over. Got my common denominator. And it feels like we're just about done, but we should do the factoring check. Is there anything I can factor on top? And there is. Actually, I can, if you come over here, let me do this as a side note. I can factor out a 2 right now. But if you notice, even when I do that, what's left on the inside is not factorable. So I could leave it with the 2 on the outside, or I could leave it as it is right now. And I think I will, because there's not much I can cancel with that. So here's my final answer. But then we should also check one more thing. Do you know what that is? Yep, domain, you got it. Let's just check our domain. What can x not be equal to? Let's just go left to right on each single denominator factor. Ready? From the left one, can't equal 1. And in fact, it can't equal negative 1, so I'll put can't equal plus or minus 1. Let me write that better for you. X cannot equal plus or minus 1. And then from the last piece, if it's just x, what makes that 0? Well, just 0. So those are our 3 domain problems. Oh, are you tired? I am too. These are pretty complicated. Again, try to factor everything first in the denominators. Looking for an LCD, I think, is one of the hardest steps. And then the rest is just busy, busy work. Okay? Now, before we go on to what's called complex fractions. That's scary. Can we just try a couple more examples of these first? Because I'm a little worried about that complex example, and I really want to try these. Make sure I feel really comfy. All right. Why don't I pause the video, and you go ahead and try this one on your own, and I'll catch up with you in just a second. Okay, so this is going to be addition and subtraction, which means we're going to need an LCD. Remember, way back when, if this was multiplication or division, we don't need LCDs. Just like when you multiply fractions in general, you don't need a common denominator, you just multiply. That was involving more factoring. But speaking of factoring, let's factor all our denominators first. Here I can just take out a GCF. That's pretty cool, because now, if we look at our 2 denominators, what's our LCD going to be? Again, I can just multiply these 2 together, and that's fine, but that's not going to be the lowest common denominator. So let's do the trick that I did before. Do you see a factor that they both have in common? Yes. And once I do that, that's gone, that's gone. What's my leftover? Is just the 3. So my LCD would be 3 times x minus 2. That's not too bad, because then what we're going to do is this left fraction just needs to be multiplied by a 3 on top and bottom. That's not too bad. A good thing is the right fraction, he already has the common denominator, so we don't have to change a thing. Yay, that's sweet. Okay, let's go up here on top where there's a little bit more room. That means my left fraction is going to turn to 3 times 3. Again, I'll keep my LCD factored just in case. Plus, remember the right fraction didn't change. All right, that's looking pretty good. So now we got our same common denominators. Let's keep it. I love that we don't have to add the denominators because that's just going to be nasty. So just keep one common denominator. Let's just add our tops. 9 plus 3, oh, it's just 12. Yay! Are we done? No, there's 2 things we should check. We should check the domain just to be safe, and we should see if there's anything we can factor or cancel. Now, speaking of factor and cancel, do you notice that I do have a 3 and I do have a 12 that are outside, meaning they're being multiplied and divided, so I can simplify a little bit. I can divide top and bottom by 3. All right, so really, here's my final answer. So it's kind of good that we did that little factoring check just to be safe. Domain, the only x that's a real boober here is the 2 on the bottom. How was that? Was that one okay? Not too bad, right? How about another example down here? This one's good. I see this every once in a while. I'm just going to get you started on this one, and I'll let you try it later on your own, where the denominators are really, really simple, very similar, but like they're opposites of each other. So what you want to do is, let's just leave this left one go, but this right one, can you make the right one look like the left one? And the best way to do that is just factor out a negative. Watch this. If I factor out a negative, the 2 becomes a negative, and the negative x becomes a positive. Well, will you look at that? Now I see I have the same factor here and here. So now my LCD, if I gather up similar factors, they both have an x minus 2, and, well, the other one has a negative 1, which you can include there, or if you want to, you can multiply the negative 1 into the top and do it that way. Either way is fine. So I'll let you go on this one, but I just wanted to show you that little trick, that if you have a denominator that looks a little bit like the other one, a great way to fix it and change it is to factor out a negative sign. All right, let's try another one for realsies. Oh, look at that one. Oh my gosh. Okay, we're adding and subtracting here, which means we need a common denominator. And a great first step is let's just factor everything. Now it looks like I might want to factor the top here, but I'm not multiplying and dividing, which is where you want to factor everything. I'm just adding and subtracting. So I only need to really factor our denominators. So I don't have to factor the numerator actually. And we'll see a little bit later why it's really good that we didn't even try. This one doesn't factor anyway, but it's good that we didn't try. Okay, let's factor this denominator. All right, how about, this is a simple trinomial. A value is 1. Methinks, how about a minus 8? X minus 8, x minus 1 works beautifully. That's kind of cool because do you notice that and So a good LCD here. They both have in common an x minus 8. And if I kind of mentally cancel those out, what's left over is just an x minus 1. So that would be my LCD. The left fraction has it. The left fraction is good to go, no touchy. But the right fraction, I do need to multiply this one by the leftover factor that I didn't use, and that would be x minus 1. Okay, so really, that would be 10x minus 10 if I want to fix that now. But just looking down the line, I do notice that I'm going to be subtracting, so I'm going to need to subtract those pieces. Okay, ready? We've got our same denominators. I think we're good to go. Why don't we go ahead and just subtract? We've got one denominator. That would be our LCD. And then the tops. How about x squared plus 5x minus 34? I'm going to pause for a second. This is exactly why I'm glad we didn't think about factoring this numerator. Because if we did factor it, in order to write it up here, we're going to have to redistribute it out and FOIL again anyway to get our common terms. So I'm kind of glad we didn't factor it. That was a smart idea, Mr. Brown. Gosh, you're so smart. Thanks. All right, now I do need to distribute this negative here, right? So this is going to be a minus 10x. Careful with subtraction. Plus 10. All right, common terms. I got my LCD on the bottom. That's just hanging out and just being chill. The top, we got x squared. I got, I think, a minus 5x, if you check my math. And then a minus 24. That looks really, really good. Okay, two things we should check. Let's see if we can factor the top, if there's anything that might cancel. And let's check domain. You know what? This one actually factors. Watch how pretty this is. This one is really x minus 8 times x plus 3, right? Oh my gosh, that's so cool because look what I have common top and bottom. I can cancel it. But wait. Before we do that, let's do domain. Remember, we always want to find domain before we cancel because we don't want to lose any of the bad values. Looking at that denominator, friends, x cannot equal 8 and 1. Right, from the denominator. Okay, now we can cancel away. The x minus 8 on top, poof, x minus 8 on the bottom, see ya. So really, final answer would be x plus 3 over x minus 1. Look at that. That was kind of nice because you do the math, and then when you're done, you should go back and factor in case you can cancel one more time. All right, great job on that. Do we have time for one more? I think we do. Shall we try it? Oh boy, here we go. Okay. So let's add or subtract these. So we need a common denominator. We should factor everything like mad. How about x plus 9, x plus 2? On the right-hand side, how about x plus 9, x minus 5? What makes factoring a little bit easier now is if you know you're going to find a common denominator, there's a very good chance that at least one of the factors is going to match. So if you're not exactly sure how to factor the second denominator, just know that you're probably going to have one of those factors in common, either the x plus 9 or the x plus 2. So look for those in the right denominator as you factor. Okay, LCD, ready? Okay, what do they have in common? They have the x plus 9. So I'll take one of those. And that's it in terms of what they have in common. So any leftovers? Yep, the x plus 2 and the x minus 5. Okay, so that's my LCD. It looks kind of nasty, but that's how we have to do it. That means I'm going to have to take my left fraction, this denominator, and see what's left. What do I still need here? I've got an x plus 9, x plus 2. I need an x minus 5, top and bottom. Okay, on this right denominator, I've got an x plus 9, x minus 5. Me thinks I need an x plus 2, top and bottom. Okay, that's great. We got the same denominators. Let me just go and distribute the tops so I can gather my like terms. And on the other front, we have 6x plus 12. But did you notice the evil subtraction? So it's going to have to distribute there in a second. All right, ready? Let's come on up here. How about same denominator, LCD, ready? X plus 9, x plus 2, x minus 5. Great. Numerators, here we go. Using the distributed versions that I made, I get 3x minus 15. Now watch this, I'm subtracting, ready? Minus 6x, ready? Minus 12 because of the negative sign. Great. X plus 9, x plus 2, and x minus 5. Okay, the tops, I've got, a minus 3x and a minus 27. Great, good job. Two things to do. Let's check domain, and let's see if we can factor the top. And actually, I think we can factor the top. Look at this. I can take out negative 3, leftovers, x plus 9. Look at that. You have that top and bottom. Don't cancel yet, though. Let's check our domain. Okay, what can x not be equal to? Look at your denominator. Walking left to right, x cannot be neg 9, neg 2, and positive 5. So check that first. Now we can cancel like silly. Ready? X plus 9s are bye. See ya. And my leftover, finally, I'll put it right over here, should be negative 3 divided by almost a complete LCD, but I canceled out one of the factors. And I get minus 3 over x plus 2 times x minus 5. All right, great work on that. So that's how we add and subtract really complicated rational expressions. We'll get into complex fractions, the last part of this section, in the next video. But great job today, friends. Have a really good day.